I'm ready now. I've
Okay.
undone my mistake.
Okay, good. I was running out of words.
Yeah, no, perfect. So to segue from where you left off there, this week we were continuing our discussion of Composer, and I have added two new examples to the Composer download that you'll find out on the GitHub link, which you'll find at the with the show notes here. 6 and 7 are the new folders, and in 6 is a long, relatively long, somewhat complex, and so we'll take our time going through it. Examination of memory usage in Corona as it relates generally to Composer. Now, some of the things we'll talk about today are not specific to Composer, but I try to discuss them in the light of Composer. And then I'll finish off with a discussion of another thing which I find really exciting about the Composer library, which is the ability to create your own custom scene transitions. So if you remember from last week, um, I demoed the transitions project where you got to see all the different transitions. I'll just show it here on the screen real quick. It's easier to talk to it. So this is what you were talking about giving to clients to take a look at. So we could do a crossfade, let's say do a zoom out, in, fade, rotate to go to the scene. So this list here is basically what comes stock with Corona, at least at the time that I wrote this example. But if you don't find a transition you like, you can make your own. You can make your own custom transition. All you have to do is sort of understand how to examine the existing ones to pull apart the pieces and build up your own, how to describe it. I'll describe it when I show it to you. How's that sound? So the point is that the last thing I'll talk about today is how to add to this list of existing transitions to get just what you want, or you can copy an existing transition and modify it slightly, which is what I generally do on client projects where the client says, I really like that transition, but this one thing. And I'm like, oh, okay, well, I'll change the sequence or the order, or I'll make the new scene come in on top instead of below, or something like that. So let's go back to our memory discussion. In 6-memory, so that's the folder that we're looking at now. And within here, you're going to find a standard project, at least the way I set up my projects. And under the IFC folder are 10 different scenes, which we will explore different memory phenomenon and topics that people have requested for this show. But to set the mood in a sense, before we even look at scenes, what I wanted to do was demonstrate the basic principle of what we're measuring here. Because there's two kinds of memory usage that if we forget about, actually there's three kinds. You could think also there is the video memory, which we are not talking about today. I'm talking about main memory usage, which is memory usage that stores game objects or Lua objects. And as I was putting this demo together, what I realized was something that I sort of knew and had forgotten, which is that Corona doesn't manage memory in all cases exactly the same way as Lua does. And so I need to demonstrate the difference so that people don't get confused when they see some behavior and they're like, oh man, I got a leak. No, you don't have a leak. What you're seeing is what Corona is doing versus traditional Lua memory management. So, set the tone. There is a file in the root directory called memsync, just for lack of a better name. And what this thing does, in a nutshell, is depending on the test type that I'm running, which is either Lua objects, and I'll show you where to set this, or display objects, it will run a test that basically creates a bunch of display objects, or it creates a bunch of tables with subtables containing a big, long string, a lorem ipsum string, just to give it something to fill memory up with. It's just it could be anything, but this was a quick way to create big table objects to demonstrate filling up memory and then releasing it. So what you'll see when you run, let's do the Lua objects first. So on line 124 or 125 of the main.lua file, you're going to see a global test type. And when you get the code, it should look just like this. It'll be set to display objects, and the Lua objects line will be commented out, and do memsync will be executed. As I go through and run this demo, I will start to use the code below, and I will comment out this, and I may choose to do Lua objects. So as far as the globals go, if you want to do Lua objects, all you got to do is comment out line 125. Basically what that's going to do is set the variable twice. The first time it'll be display objects. The second time it'll set it to Lua objects. And from then on, as it executes down through the code here, Lua objects will be the value in there. And if I save this and rerun this sample, you'll see that with Lua objects, it doesn't use up a whole bunch of memory. So it's very small. In fact, I could probably make that a little bit bigger just by adding another 0 here. I caution you, though, if you're editing this, don't leave it at 1,000,000 when you do the display objects, because otherwise you're going to probably run out of memory, especially if you're doing this on a device. For some reason, I've still got this messed up. Okay, this number should be increasing, so I've still made a mistake somewhere in here. And I'm not sure exactly what it is. All right, well, this is working in the primaries. So we'll just pretend that that didn't happen in the video here. And we'll put it on display object.
So you're saying...
The primary purpose of this was I wanted to demonstrate that, one, it produces something. So when I ran the display objects version, you'll see that the memory usage went up to 14.4 megabytes.
Wow.
So let's do it again. Starts off at 0.27. 2 seconds later, which is when this runs, it goes up to 14.1 megabytes. So if we look for do memsync in main Lua, what I'm doing is a perform with delay, 2-second wait, and all it is a function that requires the memsync file. And by requiring it, what it does is it just executes the contents. And the reason I did this example, besides to demonstrate the meter, is I wanted to show that if you require the same module over and over, it's going to execute it once and only once. So people who see this the first time, they're like, oh, well, 14.4, so that should be what, like 60 megs of use now, because you're doing it 4 times. No, it's still going to be 14.4. So we run it again. 14.1. So the point of this is when you make a module, which is what this is, every external file that you load, whether or not it returns a value, is a module. It gets loaded into memory as soon as it is required. And so you got to be extremely cautious, because unless you know what you're doing and know how to unload modules, which there is a way, and I know people will ask, and I'll say, in this show, I do not have the code in place to show you how to unload modules from memory. But if you do not unload modules, and all of your modules create huge like tables, or they use up a lot of memory. For example, one thing that some people might do is they have a module, and they may decide, hey, I need to get some textures ready for animations, so I'll make my sprite sheets. And they do the code right in the body here. They're just like, this is the code for making the sprite sheet. Obviously, it's just me typing. As soon as that executes, that sprite sheet code will execute and load. You start using up some of your texture memory. It'll start using up some of your main memory, and it will never go away. It'll always be there unless you do something to unload it. So it's just a word of caution. Be careful what you do in your modules. Don't go crazy and have every module create large objects, because you're going to fill up your memory before you ever start doing your coding. But at the same time, be aware that if you need to do some kind of caching, or you need to do some prep work, once you've loaded a module, it's loaded. From then on, every time you require it, Lua just says, hey, did I load that already? Yes, I did. Boom. And this is according to the way Lua is set up in Corona. You could set it up to unload every time, but you don't want to do that. So as Corona uses Lua, modules are loaded once and retained in memory forever. I don't think they ever clear out automatically after that.